Why does a spinning fan look like it's bending, and why do buildings lean when you pen fast on a phone? The object isn't warping. Your camera is sampling time in a weird way, called rolling shutter. A shutter is a time gate. It decides how long light hits the sensor. But many cameras don't capture the whole frame at once. They read the image line by line. If anything moves while that scan is happening, the top and bottom of your image come from different moments. Exposure is like collecting rain in a cup, longer time, more collected. Shutter time controls brightness, and it also controls motion blur. Long exposures smear motion. Short exposures freeze it. That part is intuitive. The confusing part is that shutter speed and how the sensor scans are not the same thing. Film cameras used physical shutters, discs or curtains, opening once per frame. Digital cameras still need timing control because sensors also collect light over time. But after exposure, the sensor must be read out, and reading out takes time. Most sensors can't dump the entire image instantly. They read rows, top to bottom, and that readout might take a few milliseconds, sometimes more. During that window, motion keeps happening. So the top row is earlier, and the bottom row is later. Your final frame is basically a tiny time-lapse stacked into one picture. That creates three famous rolling shutter artifacts. 1. Skew. Vertical lines tilt during quick pans. 2. Bending. Fast-moving straight objects curve, like a racket or propeller. 3. Jello wobble. Vibration plus rolling skin makes the entire scene ripple, especially in drones and handheld shots. Here's the trap. You can set a super fast shutter speed, like 1/1000, and still get rolling shutter distortion. Why? Because shutter speed controls how long each row collects light. The scan controls when each row is captured. Short exposure reduces blur, but it doesn't guarantee the whole frame was captured at the same instant. The most brutal proof is flash banding. A flash happens almost instantly, yet the camera records only part of it, because only some rows were active during that instant. Different rows were captured before or after the flash. A global shutter captures every pixel at the same moment, then reads the data afterward. No skew. No bending. No jello from skin timing. That's why it's loved in robotics, industrial inspection, and fast action. But there's a cost. Global shutter designs often need extra circuitry per pixel, which can reduce light sensitivity, dynamic range, or increase noise and price. Rolling shutter is cheaper and usually good enough for everyday video. Mechanical shutters still matter because they can help with exposure control and flash synchronization, and they can reduce some electronic artifacts in certain conditions. Many cameras mix systems, part electronic, part mechanical, trying to balance speed, image quality, and reliability. If you want less rolling shutter, avoid whip pans, move smoother, stabilize vibration, and use higher frame rates when possible. The real upgrade is faster sensor readout. Newer stacked sensors help a lot. And if your work is fast motion, pick a camera with a true global shutter. So shutters aren't just old mechanical leftovers. They're about controlling time, how long light hits the sensor, and when the sensor samples the scene. Rolling shutter is what happens when that sampling sweeps across the image. Now I want to ask you, why do some LED lights flicker or create bands on camera, even when your eyes see them as steady?